Hello, this is Reasoning and Proof, Definitions and Biconditional Statements, Example 2. Example 2 doesn't really tell us to do anything. It's just illustrating what we call an if and only if statement, and that's called a biconditional statement. And from the last section, we had statements and their converse. This is one way to represent it. We said if, and then there was something that I call blah blah 1, then, and this is the conclusion, blah blah 2. So in this conditional statement, there's this, then that, and if this is, and then we, from this regular conditional statement, sometimes called the positive, we could make the converse, and by making the converse we switch these two statements. So we'd say if blah blah 2, then blah blah 1. Well, if the positive statement is true, it doesn't necessarily mean that the converse is true. So I could say if the animal is a German Shepherd, then it is a dog. Well, that's true. If it's a German Shepherd, then it's a dog. But the converse, if it's a dog, then it's a German Shepherd, that's not necessarily true. It could be a Chihuahua or any other type of dog. So just because the positive statement is true does not necessarily mean that the converse is true. But sometimes it is. And if both the positive and the converse are true, then we can, that's a special circumstance called a biconditional. And the biconditional is the if and only if. And that's why they divided this biconditional statement into the regular conditional statement and the converse. And if both of these are true, then the biconditional statement is also true. So we look at the conditional. If three lines are coplanar, then they lie in the same plane. Well, that's got to be true, because three lines coplanar lie in the same plane. That's what coplanar means. So now we look at the converse. If three lines are in the same plane, then they are coplanar. And that's also true. And that's why the biconditional statement is also true, because both the conditional and the converse are true.